So, at the end of the last video about state machines, I wandered into talking about event sourcing, and I thought I'd try and do a short video taking a step towards that. This is actually the prep for that, but I wondered how far I would get without preparation. So I'm going to duplicate the code so I'm not breaking what's already there. We could branch, we could approach this more than one way. I just want one file I'm going to work in. I'm going to call it tell, except I can't spell tell, don't ask. And the reason to do that is it's going to be a bit easier to make an example if I arrange this code differently. At the minute it's a polymorphic state machine, so when a state machine transitions to a new state, it actually returns a new instance of a type, or itself. It could return a new instance of the same type. But what I want is a state machine that mutates for the purposes of this. So I'll always have a user, and that user will have a, to make the example easy, it will have a state as a string, as a field. Now, no, do it like that, yeah. So we're going to have self.state equals anonymous. So we'll always start as an anonymous user, and we have no way of doing anything about that. And what do we say here? Assert user transitions. If they receive a registration failed, they remain anonymous. So this code is picking up from the last video. I'll put the link to that video in the description for this one. If we look at assert user transitions, it creates a new state machine in the anonymous state. For each of the events it receives, it calls transition on that state machine with that event, creating a new state machine. And then at the end, it asserts that that state machine is of a particular instance. So we were expecting a final state. Did we reach it? This will look slightly different for us. We're now going to have a user in here. And then for each of the events in the user, for each of the events received, the user is going to transition. And differently, that's going to be a string. Is that not how you do that in, how do we do type hints in Python? There we go. So we can have assert equal user.state and final state. We should immediately see that the tests all fail because I've just broken every single test method. Yeah. Let's make sure we show the first test when it's finished, and we'll turn on the auto test runner, which I wish was a bit faster. So we're getting some help straight away. That's not the right type. Bit of a delay, it still fails. That's probably because user doesn't have a transition method. We might be getting that information down here. With Alt and Enter, let's add the method. So it's an instance method, it receives an event, and what does it do? Well, it does this. So the non-polymorphic version of this, the monomorphic version of this, would be if it's a registration succeeded event, then we're going to change self.state is going to become logged out. So if I receive any other event, my state will stay as anonymous. If I receive a registration succeeded event, my state will become logged out, and I have a passing test. Because now if I receive any event, I remain anonymous. If I receive registration succeeded, then I should become logged out. I hope we can go through these quite quickly. Registration succeeded, login succeeded, logged in. Now that should still fail, and it has done. So what we're going to get down here, I'm going to leave this as messy code for now. So if self.state is logged out and is instance event, I've already forgotten, I want to get to logged in. So if I'm logged out and I get login succeeded, then self.state is going to become logged in. That should seem how the tests go green, and it does. And we come down here. If we do registration succeeded and then we do a login failed, we should be logged out. I think we're going to get that for free because of how we've written that first method. Yep. And if you fail to log in multiple times, yeah, we're going to stay login failed again. And finally, for login failed, and the state is going to be logged. Now that will fail. We've not written that behavior. So if we look at how we've implemented that here, logged out, when you're logged out, you count the self.failed login count, and if it's over a certain amount, you return logged. So we can do the same here. I've already forgot what it's called. Failed login count. So self.whoops failed login count. It's always going to start at 0. And we can say if is instance event login failed, then self.failed login count plus equals 1. And if self.failed login count is greater than 3, then self.state equals locked, I believe. The eagle-eyed might spot we're never resetting that to 0. This isn't a complete state machine. And the other thing is, if you're really making a state machine that you're really using in your application, testing on a string field like this, that the state has been set to a particular string field, probably isn't very useful. That isn't, that's an implementation detail to make these tests fast to write, so the example appears quickly. Your application probably cares that the behavior of the application changes in some way, not that this state machine has a string set to a particular value. So, testing the behavior rather than the state of this state machine will mean in the future, if you decide you don't want a state machine, you can change your implementation and your tests remain valid. But hopefully it makes it clear now. I think it's telling me too many blank lines, but also we should be able to delete all of this now. We're not using that class, we're not using these classes, and that should all still pass. Yeah, brilliant. So that's our state machine. Why did I call this file tell don't ask? So let's write a test to see if we can demonstrate that. Def, tell me what I need to know, and it has to have test in the name, doesn't it? So you'll have heard this with multiple names, the observer pattern, listeners, RX, although it's not quite RX. But it all comes from a way Kevin Rutherford phrased it in a training course once. Tell me what I need to know. Don't make me ask. So you might have heard tell don't ask. How can I make Python happy about this? Something like that. You might have heard tell, don't ask as a principle, as a code heuristic, as a guide. You might not really know what it means. I think this is one of the ways to think of it. Tell me what I need to know, don't make me ask. So it's not uncommon to say if, so to have some kind of user and say if user.state is locked out, then, you know, what might we do? We might send alert with a destination of security team and a message that says user and user.id and has been locked out. Yeah, so we want to, when we have users who are locked out, we want to send an alert to a team. Maybe that's what happens. But here what I'm having to do is I'm having to ask the user about its state so that I can send an alert. And what I want is for the user to tell me when it's locked out, so I know what to do. What do I want? Well, I want an alerter for want of a better name. And what would happen here? Well, we would say user.subscribe to locked out alerter. And we're going to need an assertion, aren't we? Which means I probably need to know how to mock in Python, but we're going to, well, let's quickly do that. Okay, I spent a little bit of time reading the documentation of mock there. I'm not completely sure I've understood how this built-in mocking library works. What is going on? Okay, just spent a little bit of time reading the documentation. I will crop that out. So I think that we can replace the send alert method with a mock and assert that it was called once. And I'm going to have all kinds of too many blank lines. Okay, we're going to create an alerter, and if I've understood it, we can say alert.sendAlert equals mock. So I am setting up my state and subscribing the alerter to the user, and then we're going to have our events. So our user is going to register and then get locked out. For event in events, user.transition event. So at this point, we should have a locked out user, and our alert should have been sent. So why is that? Unhappy unresolved reference unit test. Okay, it looks like that. We're going to need an alerter, and user is going to need a subscribe to locked out method. It takes a subscriber, it's not going to do anything, and the wrong tests are running. So I expected mock to have been called once, and it was called 0 times. Wicked, because we didn't call it. If we come in here and say self.subscriber subscriber equals subscriber. Instance attribute, will you fix it? No, that's not what I want at all. Equals none. And then in here, self.subscriber equals subscriber. And that test should have not turned it on. So the test, we've still not called it. Now we can test that. We can say self.subscriber.sendAlert potato, and the test will run, and it should pass now because we did create an alerter, we did mock the sendAlert method, we did subscribe to the user, we ignored all of this, we sent a message to the subscriber, and we assert that it was called. So we don't want that line there, and we don't need that pass. It's here. And that test will pass. See? That was unexpected. Expected mock to have been called once, but it was called 0 times. Let's just see what's happening here. For event in events, user.transition, let's just print user.state. Have we done something very silly? It's logged out. Is this because I copied from a test without really reading it? Yes, it is. Okay. So once the user has failed to log in more than the threshold times, not the number of threshold times, then we set the state to locked and we call our subscribers with user locked. Right here we only allow a single subscriber, but you know, that could be an array, which we would call subscribers. And now this doesn't make sense anymore, but for subscriber in subscribers s.sendAlert user locked, and this is what push append, okay, subscriber, oops, and that should still pass. Yeah. So you know, we can have multiple subscribers to a single user, or we can have a single subscriber, and this method lets us choose. And what's happened in the flow of our code here is that our alerter doesn't have to ask questions of the user. The user tells the alerter what it needs to know, and the alerter tells the user what it needs to know. The user needs to tell who its subscriber is so that it can send a message. And you know, you'll find this is a really useful way to avoid that procedural list of things that have to happen way of writing code. It's a little bit more like little machines passing messages to each other. So let's commit there. I can subscribe to users if you have a send alert message. So sure, here we've not given any type hints here, so you know, any old object could be passed into subscribers, but they all have to have send alert. So you know, you could have an interface or what have you, or you could make this message a bit less specific. But I think the thing maybe to tackle here is that these two items are really tightly coupled together. User knows about subscribers, alerter knows about users, and actually because that message the send alert message that has to be sent is so specific. Really, user knows about alerter. So we're doing tell don't ask, but we're still really tightly coupled together. If this is the only time this is going to be used in the application, maybe that's fine. You don't need any more wiring. But this is the point where you can start to walk towards event sourcing, or we're already event sourcing. The state of this user object is determined by the events that it receives. It doesn't. We could throw it away and recreate it. It really doesn't matter. The state, the individual instance of the object doesn't matter. And so we've event sourced this object. But really what we want is an event stream. I haven't prepared this. I haven't thought about this even at all. So what would that test look like? Well, we're going to have a user, and it would know about an event stream, which means we need to have an event stream. And we're going to have an alerter. And it is going to subscribe to the event stream. And it's going to subscribe to user locked out. That's what it cares about. It's going to give itself. So we'll have a user. The user knows about the event stream. It intimately knows about the event stream. And we're going to have an alerter, and the alerter knows about the event stream, but only that it can subscribe to events of type user locked out. What comes next? What comes next is that we've written an application that only takes one. There's only one user in this application, which isn't very useful, but okay, let's not worry about that too much. We're going to have this again, but actually we're not going to pass these events directly to the user. We're going to say event stream.send event. And we're going to set up our mock again. And then at the end, we're going to say that after all of that, the alerter will have been called. So let's just break the code. I'm going to get rid of that. I'm not going to worry about the fact that this will be broken by what we do next. We're going to create an event stream. And we're going to come down here. We're going to say users never used. But we're going to create a user and give it the event stream. I don't actually care about the user. In fact, we can do this to prove that it's happening. We can say assert is equal. Okay, just had to go and be a father. I will try and snip that delay out. Just picking up after a delay. We're going to assert that this is assert.is. What's going on? Why isn't it helping me? Assert equal. Well. Self dot assert equal user.state is locked out. So at the end of this process, even though we're not passing directly any information to the user, our user will be in the state locked out, and the alerter will have received a message. It's not doing right now because we're now passing an event stream to the user. So we can say event stream, and we can be really Can't just pass me any old stuff. What's it unhappy about? Unresolved reference. Okay. Like that. Okay. So it has to be in an event stream. And we're going to keep ourselves a record of that. We're not going to have subscribers anymore. We are going to have a state. We are going to have a failed login count. We will still transition. We no longer need to subscribe. And in here, we are not going to send the same problem, aren't we, that this is down here. So in here, we're not going to directly send the message. We are going, and we're not going to have a bunch of subscribers. We're going to say self.eventstream.send user locked out. Now, really, this user should have an ID, and at least that should go into the information about which user was locked out. So doesn't have a send method. So what have we got here? This is the event, and what does it do with that event? Who knows? We haven't decided yet. What's the complaint here? Too many blank lines. Should really just set something up so I don't have to think about that. What do we have here? Subscribe, and we subscribe to a type and give ourselves. So let's add that method, def subscribe. Subscribe. We're going to have an event type. I'm going to have the subscriber. So let's have a self.subscribers, and it's going to be a dictionary. And I'm going to write some unsafe dictionary code because right now we're only going to have one subscriber. So in here, we're going to say self.subscribers event type. I'm going to hope that's hashable equals subscriber. So what we're doing here, we're having subscribers. The subscribers can subscribe by event type and add themselves to a list. If this code was safe, it would check if there were already any subscribers, and then add the new subscriber or create a list with just this subscriber. For now, we're going to do this dodgy version. In send, we've got an event. In send, we're going to say for subscriber in self.subscribers event. This isn't going to work at all, is it? This is my very bad Python knowledge showing now. We're then going to say subscriber.send event. It's definitely not going to work. Let's see if my brain doesn't work. Let's see if these error messages guide us towards a working implementation that isn't nonsense. So key error for subscriber in self-subscribers event. When we're calling eventstream.send, here we're receiving a class, we're passing it into there, and that's not worked. Let's say Python get type of object variable, whatever, and we say type. So print type of string gets class string. The return value of type is type. Okay. Python get type of object as string. What do we say here? underscore name. Okay, so type of event underscore name. We're going to do the same here because this is the it's the event. Type of the event underscore name. So that should be indexable now because it should be a string. And what have we got now? Key error, registration succeeded. For subscriber in self-subscribers. Presumably we're getting a key error because it's not there. Let's see. Print self.subscribers. We're getting the word type. Has a random Stack Overflow has finally let me down. Type proxy. I don't want to do that. I wrap it in string instead. So I want a string. I want a string. What happens now? Key error of blah when we got class type. So let's look back at this test code. User locked out. Well, that's different, isn't it? We are literally passing a type in. Whereas now, okay, now we're getting somewhere. So what we had there was class U pass. So I should be able to say x equals U. Okay, good. And then I can say type x. Okay, so we get that. But I should also be able to say type U. And that's a type. And if I say U, we get that back. So in what I'm doing right now, I don't want my subscriber to have to initialize an instance of an event in order to subscribe to the type. So if we do here, this is the event type again. So I'm not going to say type. I'm just going to say string and see if we go str u. That looks a bit close to what I was hoping it would look like. So now when we look at our subscribers, you can see here we've got a key of user locked out, and when there's a user locked out, then my subscriber is this instance of an alerter object. When we come down here, it says key error, registration succeeded. So I've said for each subscriber in self-subscribers blah, for self-subscribers for event type. So give me all the subscribers keyed by this event type and then loop over them, and Python's saying that there are no subscribers, like that isn't a key on this object in this dictionary, so presumably there's a get that might still give me a key error. Non-type is not iterable. Does get have a default, get and a default. So get me that or an empty list. How's that? So look, I confidently said we'll write the unsafe version, and then the unsafe version didn't work. So what's happening here? We're printing our subscribers out every time we hit send. We've printed the subscribers out multiple times. Locked out isn't anonymous. We expected anonymous. We actually got locked out. Now, why is that? Well, it's because we haven't actually taught the user object anything about this, have we? Let's look at this. On the event stream, we have a user object. Down here, as part of this thing, we're now saying event stream send event. So we're sending the event stream into here. We're saying for that one, for this event type, get me all the subscribers, and there are none. For each of those events, there are none. So, well, what do we want to do? Let's do this. Self.subscribe all. So anyone that's subscribed to this particular event type, and for subscriber in self.subscribe all, subscriber.send event. So you can subscribe to a particular event type, or you can subscribe to every event type, every event. So we need a method for that. Subscribe all, self, and subscriber. Subscriber, self.subscribe all. There's my dog is not being looked after. She's found her chicken toy. Throw my chain of thought. Subscribe all. That's not the code at all. This is now a list, so we want to append this subscriber. Now, still broken. And then what we want to do is we want to say self.eventstream subscribe all self. What's going to happen in here? It's going to call send. Okay, well, no one's calling this method, so let's have send. What do we have now? List object is not callable. What have I done? Dip, 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 dip. Self.subscribe all. Is it this line that it's complaining about? No. Self.eventstream subscribe all. Oh, it's it's a name collision, isn't it? Okay. See, I am learning a lot about Python, and I've lost my code. What am I looking for here? Event stream. Let's call this subscribe to all, and then in our user we can say subscribe to all, and that should run. And alerter object has no attribute send because we didn't mock it. Let's try that again. And it unexpectedly fails. Assertion error locked isn't locked out. Okay, so what happens up here? If login failed and the count is greater than 3, then I'm going to set the state to locked. So, okay, great. Now it's going to be green? No. Alerter object has no attributes and alert. Okay, we renamed it. And now it passes. Okay, awesome. So we now have an event stream. Our user is aware of the event stream, and can register to receive every event that the event stream receives. We have an alerter. It can subscribe to receive particular types of events from the event stream. We can send events to the event stream, and the application works. So now user and alerter are no longer tightly coupled. They don't know about each other. User knows about the event stream. It knows that it can receive events from the event stream, and it knows it can send them. Excuse me. Alerter knows it can subscribe to the event stream, and it knows it can subscribe by passing a type. But that's fine. We can tightly couple user to the event stream because user relies on the event stream for its behavior, and we can tightly couple alerter to the event stream because alerter relies on the event stream for its behavior. We've removed this coupling between alerter and user because they don't depend on each other. They could exist at different points in time in the code base. You could not deploy alerter and user would still work. And now, more and more, as this code changes, this set of events that are received become the truth. You know, I can add more subscribers to these events. I can, you know, I could have a count all failed logins subscriber. It's anything you can think of. You can now, you can build it off this event stream. If you try this out, you will find, I hope, like I did, it's a really cool way of making applications. It's a really nice way of making an application where you add stuff. You want a new feature? Wicked. I'll add a new subscriber. And then when the feature doesn't work, you just stop deploying the subscriber. It's super cool, in my opinion. If we kept going with this is not, don't copy and paste this implementation. This isn't a good implementation of an event stream. We would quickly find that this should become event store, and that the event store should have streams. And I guess I'm going to stop now, and that's going to be the next video. The next video, we're going to turn this into an event store that has streams. Our subscribers will be able to subscribe to streams or projections, and we'll rejig this code to show how that would work. And at that point, we'd be ready to start pulling in other people's event stores to see what they might look like. So yeah, I'll edit this to take out my kids interrupting me and the dog barking and stuff, and me Googling how Python mocks work, and next time I'll turn event stream into an event store. Cool. Thanks for listening. I hope it was interesting. You can get me on Twitter at PaulDambra if you want to ask me questions about it, or comment on it.